So the objective today is going to be to show what extrema are, and to do that graphically, and then to show how to find them. Show how to find them. So let's first look at an example. So let's say that I draw a graph. It's going to look like this, and I mark -1 here. Here's 1, here's 2. And I'm going to draw a function f of x that looks something like this. So this is my function f of x. It's defined here, here, and here. And these points correspond to x is equal to -1 and x is equal to 2. So this is f of x. And I'm going to say that f of x is continuous, and the interval -1 to 2 is closed. In this particular case, because all the points are defined, I'm going to say that this right here, this is a maximum, and this right here is what we would call a minimum. But let's look at another example where this might not be the case. So let's go ahead and redraw this graph one more time. And we have a -1 here, a 1 here, and a 2 here. And I'm going to redraw our function f of x. It's going to look something like that. And I'm going to add a discontinuity here and a discontinuity here, but it is defined right here. And we're going to say that f of x is continuous in the open interval from -1 to 2. So this is an open interval. In this case, because these values are not defined, we cannot say that these are maximums or minimums. Here, we can say that this is a minimum, but this is not a maximum. Let's go ahead and look at a third example. Let's go ahead and draw this one more time here. And we have -1, here's 1, and here's 2. And let me draw this function again. So there's my function f of x. And what I'm going to do is I'm going to define it here. I'll go ahead and do that in black. Defined here. It's defined here. But then there is a discontinuity here. And we will define it instead right here. So just in case anything here is not clear, this right here is a discontinuity. In this particular case, we would say that f of x is not continuous. And we're working in the closed interval from -1 to 2 is closed. And so in this particular case, we would say that this is a maximum. But this point right here, because the function is not defined, we would say that this is not a minimum. So you might be starting to get the idea of what a minimum and a maximum is. But just to kind of show you what that looks like, I'm going to just draw one more example here. So here's a very large graph here. And I'm going to draw a function that looks something like this. And we're going to call this function right here f of x. And I'm just going to note a couple of interesting points here. So we're going to note this point at the very top here, this point at the very bottom here, this point at the top here, this point right here, this point up here, and then I'm going to choose a point perhaps right here. And we're going to label these points. We're going to call this point up here, this is an absolute maximum, because it is the maximum value of this function. None of these other points are larger than this maximum value. So this is an absolute max. We call this a relative max. And we're going to call this one right here a relative max as well. How about this guy right here? We're going to call this a relative minimum. And this is because the function reaches a minimum here, but it is not the lowest minimum. So here we call this one a relative minimum. And this one right here, well, this is neither a minimum or a maximum. However, if we did end the function right here, we could call this one our absolute minimum, because there's no value of the function which is lower than this point.